Okay, dear student, let's see what is there in this question. When tritium decays by beta minus decay, one of the products is a stable isotope of helium. Outline what is meant by isotope. So first question is, what is an isotope? So isotope, as we know, they are the nuclei of the same element, which have the same atomic number, but they have the different mass number. And why is that? Because they have different number of neutrons. Proton is the same, they have different number of neutrons, that is why they have the same atomic number but different mass number. Like hydrogen, 1 1, and then deuterium, and then tritium. These are the isotopes. But let us now concentrate on the next question. Identify for the helium isotope produced in the tritium decay its mass number. So what is the new mass number for the helium isotope that is created here? Let us write the reaction first of all. You see, this is beta minus decay, and so we remember it that in beta minus decay the atomic number increases by 1. So clearly the hydrogen is converted into helium, and that is also given in the question itself, so there is no doubt about it. So what is happening? This is converted into helium, so atomic number is going to be 2. Mass number I don't know, so I'm not writing it. But beta is electron, and whenever electron is produced there is antineutrino also, which is this. So these are the things. And obviously if you refer to the topic 7.3, that is Feynman diagram or other, the exchange particle in this kind of reaction is W minus. Always this is the thumb rule, okay? So you can even remember them. Anyways, coming back to this question, now we can use the rule. Well, there is a name of this rule. That rule is called Soddy-Fazan rule, but the IB books are not telling you about the name of the rule, but they are using the rule. So Soddy-Fazan rule is that the addition of the mass number will be same. So 3 is equal to this plus 0 plus 0. It means this has to be 3. 1 will be equal to 2 minus 1 plus 0, and that is equal to 1. This rule is called Soddy-Fazan rule. Okay, and accordingly we can say that the mass number is going to be 3. Proton number is obviously going to be 2 because it is helium. There's no doubt about that. So this is how we do it. So I will be showing you the mark scheme later. Outline the quark change that occurs during this decay. Time and again the same question, just like the method of asking is different, but they are referring to the same beta minus decay. You can even remember these beta minus decay and beta plus decay. Wherever you find it, just remember it, okay? You would be getting this question. Now this is beta minus decay. So beta minus decay occurs in the atomic number increases, so neutron has to break down into proton, thereby electron is created, and whenever there is electron, antineutrino is created. Okay, it's like this. So this is the disintegration of neutron which is taking place. So neutron is like down down u. You can even remember it, just like there is a protest going on in your city and it's like down down you against neutrons, okay? But for proton it is always up up down. It's like up 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 for the proton. So proton is up up, and one quark is down. So this is just another method of remembering it, okay? Now so this is DDU. So D is not changing, so D is remaining as D, U is remaining as U, but this one D is converted into U. So quark change that is actually taking place here will be written as D is converting itself into U. This is what is going to happen, isn't it? This is the quark change that is happening. That's it. So this is the answer. Okay, let us now move to the mark scheme and see what is the answer for this question. Question number 5A. Yes. An atom with the same number of protons but different number of neutrons, they are called isotopes. So 3 was the mass number, 2 is the proton number. Yes, exactly. And the quark change that takes place in this reaction is D to U. Okay. If they ask about the exchange particle, so that will be W negative boson. So you must be knowing it. Let us now move next. So this is done. Outline the quark change. Yes. Compare the properties of strong nuclear force and of the electromagnetic force that allow the helium nucleus to be stable. Compare the properties of strong nuclear force and of the electromagnetic force. Okay, I don't know what to write in this question. I mean to say, as a student, I can think of what to write in this. This is giving 3 points there. Compare the properties of strong nuclear force and of the electromagnetic force. Well, the properties will be, we can clearly say that the strong nuclear forces, they are short range, and that is why there will be attraction between the proton and the neutron, because they are even charge independent. In electromagnetic forces, they are usually taking place when charges are involved, like positive charge and the negative charge of the electron, they are involved. So that is the electromagnetic force, that is Coulomb force they're talking about. So that could be the answer. Okay, sorry for this, we will be referring to the mark scheme and see what they are doing. Okay. Yes, strong force is short range. Ironically, it is the first reason that I gave you. Electromagnetic force is the long range. They are just comparing it, and they are not even telling why are these things important for the stability of the helium atom. But still, they're just comparing these two, and they're just giving the differences that we can write anytime. So I believe IB should be more, like, this question could have been more explanatory. Like, what is the question asking, isn't it? So strong force is short range, no problem. Strong force is attractive between neutrons, and I told you, and neutrons and the protons. But electromagnetic force is attractive in electron and proton, and repulsive in proton and proton, like that. Overall, the strong force dominates. Oh, this is the reason that they want to say that why the nucleus is becoming more stable, because there are protons there, and yeah, there are two protons there in the helium. So why is the stability there? So we would be saying that the the nuclear forces are stronger, and that is why they dominate the uh, Coulomb force. That's it. Anyways, this is a theory question, like in theory question, I have this reasoning that it is always better if you read the answers given by IB. Like, it will make you judge, a better judge, like what is it that IB must be looking forward to. Like, we can even use the same terminologies to write your answer in your examination. So this is what they want, according to that. Okay, now let's see what is there in this. A beta minus particle and an alpha particle have the same initial kinetic energy. Outline why beta minus particle can travel farther in air than the alpha particle. Okay, the reason for this is clear, that alpha particle is actually the nucleus of helium particle. So nucleus of helium atom is consisting of two protons and two neutrons, which is kind of 4,000 times heavier than electron, than the beta particle. 4,000 times more. Okay, 4,000 times. Like, that is too much. It's kind of 4 tons. So when uh, this truckload of 4 ton material is going to hit this 1 kg material, by the way, so what will happen to the electron? Obviously, electron will fly away, isn't it? Okay, so beta particle is very small in size, alpha is big in size. Moreover, alpha is charged like 2 plus, and it is heavy. Its velocity is lesser. Alpha's velocity is kind of 90% of the speed of light, you can say. And sorry, 92 to 95% of the speed of light. Electron is moving, beta particle is at 99% of the speed of light. So this velocity is higher, this velocity is lesser. On it, it has more ionizing power. Ionizing power means that, um, let us say there is a gas here, and alpha is passing through it, like this. So it is going to hit many electrons, it is going to hit many atoms inside. So all the electrons are going to cling to the helium nuclei, and there is a chance that the alpha particle will be converted into helium particle, like inert gas. That is one molecule gas, isn't it? So one atom gas, isn't it? Monoatomic. So it can convert itself into helium gas there by attracting electrons. So obviously, we will say that the alpha is not able to survive, because there is a high chance that it will be taking away the electrons from the other gas, thereby creating ionization from them, and converting itself into something else, isn't it? Like this. So that could be the answer. Let's see what is the answer which is given by IB. Alphas have double charge and so they are better ionizer. Alphas have more mass, therefore they are slower, longer time, more likely to interact with the electrons, and therefore better ionizers. Yeah, they are better ionizers, and obviously there is a chance that they can attract more electrons, isn't it? Size is bigger, that is why the penetration power is lesser. So many reasons are there. Okay, so this is it. I think that could be the last question for question number 5. Yes. Okay, dear student, thanks for watching the video. Please, if you have some comments, like if you like the video or if you do not like the video, by the way, you can message that in the comment section. No problem. All the best. Bye. See you in the next video. Please share the video with your friends.